In this lecture, we'll see a problem on analogous systems. So, the question is, for the physical system shown below, draw its equivalent system and write equilibrium equations, and hence draw its electrical analogous circuits based on force voltage method. So, this is the given physical system. I have redrawn it to represent the displacement here. So, once again I have drawn it here. Now this mass m, okay, because of the applied force f of t, it will displace by x of t. This is nothing but the displacement, okay, which is caused due to the application of the force f of t. Now here k is the spring which is attached to the fixed support, and also that is, it is with respect to the fixed support, and also b, which is nothing but a friction, it is also with respect to the fixed support, and k and b both are under the influence of the displacement x only, okay, because here we have only one displacement, therefore these two are under the displacement of that is, these two are under the influence of the displacement x only. Now we will draw its equivalent system, which will contain one node. Why one node? Because here we have only one displacement. The number of nodes will be equal to the number of displacements. So because we have here only one displacement, therefore we will be having only one node, and all other elements will be under the influence of this node alone, that is the x of t, and all these elements, that is the spring, mass and the friction, these all will be connected in parallel under this node, okay. So now I will draw the equivalent mechanical system. So I will draw the equivalent mechanical system. You have only one node, so we will take one node, that is x of t, or you can write it as only x. Now you have the applied force f of t, therefore here I will write it as f of t, okay, first element. As these all are under the influence of the single node or the single displacement, these all must be connected in parallel under this node. So next will be our mass, okay, next is the mass m, then you have the spring k, then you have the friction, okay, sorry, this k it is represented by a spring, I'm sorry, okay, it is k. Then you have the dashpot, that is the friction, which will be represented by a dashpot, that is b. These all are under the influence of the node x of t only, okay, and these all are with respect to the fixed support. So this is what? This is the equivalent mechanical system. Fine. Now we need to write the equilibrium equation for this. Because there is only one node, there will be only one equilibrium equation. Now as we are applying the force f of t to the mass m on the LHS side, you will be getting it as f of t, that is equal to, as we all know that along with mass you will be getting the acceleration, and along with the dashpot or the friction you will be getting the velocity, and with the spring you will be getting the displacement, okay. So here what we'll do now, mass m, it will be equal to, acceleration is a double differentiation of the displacement, so we'll write it as d square x of t by dt square. Then next you have second term with respect to the friction, okay. So b, v is the velocity, velocity is the differentiation of the displacement, so we'll write it as dx by dt plus k into x of t as it is. You write it as x of t or x, it is okay. Now next we will take the Laplace of this, okay. So what we'll do, take Laplace of this equation. When you take Laplace of this equation, this f of t, it will become f of s, that is equal to m into d square x of t by dt square, it will be s square into x of s, plus b into dx of t by dt, it can be written as bs into x of s. Then you have k, this x of t, it is simply written as x of s. Okay. Now next you have you need to draw the electrical analogous circuit based on the force voltage method. So we need to write all the analogous elements with respect to the force voltage method first. So we will list the analogous elements with respect to what? With respect to force voltage method. Okay, so when you write this, first is the mass, it is analogous to the inductance. Then you have the friction, which is analogous to resistance. Then you have spring, which is analogous to the reciprocal of the capacitor. You have the displacement, analogous to charge. You can write this as dx by dt, that is equal to dq by dt. So rate of change of charge, that is equal to current. And one more is the displacement. It can be written as this x, it can be written as what? Integration of the current, that is integration of I dt. Then you double differentiate this, d square x by dt square. This you can write it as di by dt. So you must remember these, then only you can write the equation in the form of force voltage method. Now what we will do, we will replace the elements in this equation. I'll take this as equation 1. You have to replace the elements with these analogous elements. Okay, so now this is force voltage analogy, therefore force is replaced by what? Force, I'll write force is replaced by voltage. Okay, this f of s will become what? This will become v of s. Before that I will write all the quantities which will be expressed in the current. Okay, that is current I. So I will take this equation first, that is this equation. Okay, f of t is equal to m d square x of t by dt square. This equation I will convert it into the analogous to force voltage method. So f of t will become what? It will become v of t. Okay, f of t will become v of t here, this one. Next, m is analogous to inductance, so m will be replaced by inductance. This m is replaced by inductance. Next, d square x by dt square. D square x by dt square, it is nothing but what? It is di by dt. So I'll write it as di by dt. Then plus, next b is analogous to resistance. Okay, next you have dx of t by dt. Here we have dx of t by dt is I. See here we will not write the expression in terms of this charge. Okay, we will write the expression in terms of the current. So next here we have k. K is what? It is the reciprocal of the capacitor. And then you have x. Where is x? X here. Okay, x is integration of I dt, integration I dt. Okay, now we will write the Laplace of this equation. So Laplace of this equation will be v of s, that is equal to di by dt. So this can be written as what? It can be written as this is L as it is, di by dt, it can be written as s into I of s. Okay, s into I of s. Then plus, next you have this capacitor. So here integration I dt, it is nothing but I of s divided by what? Divided by c. Okay, then plus r into I. So I is what? I is I of s into r. Okay, So you take this as equation 2. Now what we have to do, we have to draw the electrical analogous system. So for that, so here this is the force voltage method. Therefore when you opt the force voltage method, all the elements will take the form of a loop. Therefore here what we have inductor, we have capacitor, and we have resistance. So here first I will draw the inductance. This is L. Okay, then you have the capacitor C, and then you have the resistance R. Okay, these will be connected in this form. These will form a loop. So here input is V of T, that is voltage, and you have current here. Okay, now this C is what? C was reciprocal of spring, or spring was reciprocal of what? It was reciprocal of 1 by C. Therefore here you need to write it as 1 by K. Remaining, this L was analogous to M and R was analogous to B directly, so no need to write anything here. But K was analogous to 1 over C, therefore you have to write it as in bracket, you have to write it as 1 by K. So here analogous to K is the capacitor, but its value is what? Its value is proportional to 1 by K. Therefore it is indicated by writing it as 1 by K in the bracket and near to C. So in FV analogy, the quantities which are under the influence of the same displacement in mechanical system, those will carry the same current in the analogous electrical system. So this is how you have to solve the force voltage method.